standard number 2, functions. This essential standard tends to be hard for students, partially because there's so many things we ask you to do. First, there's operations. Can you add them? Can you subtract them? Can you multiply them? Can you divide them? Then there's inverse. Can you find the inverse? Then there's composition. Composition is the f of g and the g of f. I'm sure that's your favorite. Okay? So, let's say we had that f of x was x squared minus x minus 6, and we had g of x was 2x plus 3. F times g, you're distributing the 2x to everything. 2x cubed minus 2x squared minus 12x, right? Shh. In the back, shh. Right? You distribute the 2x to everything. Is everybody with me? Now you distribute the 3 to everything. So you get plus 3x squared minus 3x and minus 18. And you end up with 2x cubed plus x squared minus 15x minus 18. It really doesn't get interesting until we ask you to do f divided by g or g divided by f. That's really when it becomes something new. So, the key to f divided by g and g divided by f is really not the division of it, it's the domain restrictions, okay? So f divided by g simply means you take the f of x function and put it in the numerator, and you take the g of x function and you put it in the denominator. And then comes the part that's actually interesting, and that is domain restrictions. Anytime you have a variable in the denominator, you have something that x can't be, because you're not allowed to have a denominator with the value of 0. The way you find your domain restrictions is you basically take the denominator and you say that it cannot become 0. Once you solve that out, you get that x cannot become a negative 3 over 2. So f divided by g, the answer to f divided by g is right here. It's the f of x function, x squared minus x minus 6, over the g of x function, 2x plus 3, such that x is not a negative 3/2. I'm going to do the reverse. G divided by f. What do? You put the g of x function in the numerator. You put the f of x function in the denominator. You take the g of x function and put it in the numerator. You take the f of x function, you put it in the denominator. Now, the denominator has just become quadratic. Now that means there's not 1, but 2 domain restrictions. When you have a linear equation, you solve it a certain way. When you have a quadratic equation, you should consider factoring it. It factors to x minus 3, x plus 2. Now you set them both to not equal 0, the same way you did this one. So you say x minus 3 cannot become 0, x plus 2 cannot become 0. Therefore, x cannot equal 3 and x cannot equal negative 2. So g divided by f is the g of x function in the numerator, the f of x function in the denominator, with not 1 but 2 domain restrictions that were found by factoring and using the zero product property. Inverse. Inverse tends to be the one that students find difficult. And the fact of the matter is that inverse is a very important idea as you go along in math and you take math analysis and calculus and things like that. You really need to understand the idea of inverse. If the g of x function was 2x plus 3, like we said it was before, The notation to ask you for the inverse is for us to take g and raise it to what looks like a negative exponent. This does not mean g to the negative 1 of x. It means the inverse of g of x. The answer is not. This is no. This is what a student does that's not paying attention in class. They say, is it 1 over 2x plus 3? No. That is completely wrong. What do you do? If g of x equals 2x plus 3, and you want to find the inverse of g of x, the steps go like this. You change g of x to y. You say y equals 2x plus 3. Now you let the x and the y what? Switch. Because that's what inverse is. Inverse is when your x or your domain becomes your y, your range. And conversely, your y, your range, becomes x, your domain. They switch. So change g of x to y, switch x and y. Now solve for this y using algebra. Subtract 3 from both sides. X minus 3 equals 2y, and divide by 2, and you get y equals x minus 3 over 2. And the last step, change your notation back to the inverse of g of x. And so you could say the inverse of g of x is x minus 3 over 2, or your teacher might want you to write it as 1/2 x minus 3/2 by basically taking the 1 over 2x minus the 3 over 2.